Welcome back, dear students. Uh, Today we are going to have a comparison of CIDR versus VLSM, and this comparison we will try to solve this requirements or this solution problem. With the help of this practical problem, we will try to understand that how VLSM is more efficient than CIDR and how VLSM support resubnetting of subnet. Okay, so here this is our requirement. Suppose I have a class C public IP address 200.150.100.x. So I have a 100 network and I require to divide this one network into four subnetworks because there are how many customers? Four customers. So required subnetworks is equal to 4. Okay, and here is the required number of hosts per subnetwork. As you can see here, the required number of hosts per subnetwork is, for the customer A is 50, for the customer 2 is 25, and for the customer 10, and so on 2. So 4 networks in 50, 25, 10, 2 per subnetwork host. So I require to do what? I require to do subnetting. I require to subnet this. Subnet. Okay. So how we can do this? There are two methods, CIDR and there is VLSM. CIDR and VLSM both are used for the same purpose, but VLSM is more efficient. More efficient mean what? More efficient mean further decreased the wastage of host addresses per network. Okay, how it support this? Because the VLSM support what? Resubnetting of a subnet. It support resubnetting of a subnet. Okay, and here in CIDR it will give us equal number of CIDR will give us equal number of host addresses per network. It's not flexible, just like our requirements are different, but it's not flexible. It will give us equal number of host addresses per subnetwork. So definitely it will lead us to wastage of host addresses per network. Okay, now let's prove it, how it will give us fixed number of host addresses per network and how it will wastage our addresses and how VLSM is more efficient. Okay, so first of all we will go through CIDR, then we will go to VLSM. Okay, so let's carry on. Okay, before that, how many subnetworks are required? 4 subnetworks. Okay, so 150, my IP address 200.150.100.x. How many bits shall I borrow? I mean, what will be the CIDR value which will give us 4 networks and minimum 50 host IP addresses per network. Remember, minimum 50. Okay, you have to here you have to consider the maximum one, which network, the maximum number, that should be the minimum number of the network, which will give us the host addresses. Okay, so the CIDR value should be 26. Why 26? Because in 26, here we borrow how many bits? Number of borrow bits are is equal to 2. So how many sub networks will be given there? Number of sub networks is equal to 2 to the 4. So 4 sub networks will be available, and my requirement is also 4 sub networks. Okay, what will be the number of host per sub network? Number of host per sub network, 2 power 6. How many host bits are remaining over there when the CIDR is slash 26? You know, total number is 32 minus 26 is equal to what? 6. Okay, so 2 power 6 minus 2 is equal to 62. And now you can see 62 is greater than what? 50. It means this CIDR slash 26 can give us host addresses for the customer 1, customer 2, 3, and 4. Range of each subnetwork, which is very much simple, the last octet divided by 4. 256 divided by 4. 256 is the last octet total range. Why 4? Because we have 4 subnetworks, so is equal to 64. The first network, subnet 1, subnet 1 start from 200, 150, 100, 0, 200, 150, 100.63. Subnet 2, 200, 150, 100, 64, 127. And here subnet 4, 192, 160, not 192. Our address is 200, 150. 200, 150, 100.128, and finish on 200 and 191. Okay, if you are confused, don't be. See, in each subnetwork I have the range of 64. So one start from 0 to 63, 64 to 127, and 128 to 191, and 192 to 255. If you are confused how, plus 64 with the 63 plus 64 with this, it's 127, it will give us 191, plus 64 with 191, it will give us 255. Subnet 4, (192), not 192, 200, 150, 100, 192, 200, 150, 100, 255. Okay, so now this subnet 1 will be given to customer 1, C1. This will be given to customer 2. This will be given to customer 3 and customer 4. Okay, these are the subnetworks for each customer. I required to have 4 subnetworks, and CIDR give me what? 4 subnetworks with the subnet mask of 255.255.255.192. Now come back. Equal number of host addresses per subnetwork. So you can see in each subnetwork the number of hosts is what? Equal. Like 64 is here, 64 is here, 64 and 64. Okay, wastage of host addresses per network. Yeah, there is wastages. Like in customer A were required to have how many IP address 50, and I'm giving them how much? I'm giving them 62 minimum. Okay, it says 64 but minus 2, customer. Okay, the next customer required addresses was how much? 25, 25, 10 and 2, and I'm giving them what? 62, 62, 62. And now, so this is the available addresses, this is the required addresses, and here let's find the waste addresses. Okay, so 50 minus 60, 62 minus 50, so 12, and 62 minus 25, 37, 62 minus 10, 50, 62 minus 2, 60. So total wastage is how much? Total wastage is 159. So this is the wasted number of host addresses. Okay, dear students, without subnetting, we were required to give to each customer a class C network, like to one customer 100, to another customer 101, 102, 103. And in that case, in each network, we were wasting hundreds of IP addresses. But with the help of CIDR, we decrease that wastage. We decrease it, and we still we have this much addresses, which is still not acceptable. So the next method is what? VLSM, variable length subnet mask. There is whatever will be the required number of host addresses. Accordingly, we will do what? We will do subnetting. Once we did subnetting, then if our requirements is variable, not constant, accordingly we can change our subnet. Okay, and that's called resubnetting of a subnet. So let's solve the same problem with the help of VLCM. Okay, required number is what? Customer 1 is required host 50. Okay, so our IP address is 200.150.100.0. So here I will take what? /26. /26 will give me what? Will give me 6 host bits are remaining there, so 2 power 6. Number of networks are how much? 2 power n, 2 power 2 is equal to 4, and 2 power 6 minus 2 is equal to 62. Okay, so for the customer 1, I will give them the network 200.150.100.0 up to where? 200.150.100.63. so this is for the customer 1. Okay, still customer 1 will have 12 extra IP addresses. Okay, next, customer 2 was required how many addresses? Customer 2 was required 25 addresses. Okay, so now /26 is giving me 64 addresses per network, which is more than my required number of addresses. So I should decrease the number of hosts. Like, let me use 5 host bits. 2 power 5 is equal to 32, minus 2 is equal to 30. So 30 and 25. Here I have minimum number of wastage. So I will take CIDR value 27. 200, 150, 100 dot, for example, 0/27. Remember, I write here 0, but 0 is already used. Okay, 0 is belongs to this network. Okay, so I can write 0, but you have to keep track of the previous addresses. Okay, 64. Now it makes sense. Okay, so I have per network 32 number of host addresses, and I shall start onward of 64. 64 will be my network address. Okay, my first wallet address will be 65, but where I will be stopped, simple, I have to count what? 32, like this. 63 plus 32 is equal to 59. So my last address is what? My last address is 95. If you think that why 63, because 63 was the last address. Okay, plus 32. 32 is my total number of host addresses which should be added. Okay, this is for the customer 2, and customer C was okay. Subnet mask is changed now. Okay, let me write the subnet mask. Here the subnet mask was what? 255, 255, 255, 192. Here 255 dot 255 dot 255 dot 224, because 3 bits are borrowed. Okay, it was 92 because 2 bits were borrowed. Come to customer 3. Requirements was how much? 10. Let me confirm this. Yes, 10. So what should be the value of 2h to give me minimum 10? So the value of this will be 2 power 4 is equal to what? 16 minus 2 is equal to 14. So 14 is greater than what? 10. If we will borrow more bits, like we will leave there 3 bits, then 2 power 3 is equal to 8. 8 is less than 10. We cannot take that. Okay, so 2 power 4 is good. 2 power 4 mean the host bit. So when the 4 bits will be there for the host, so how many is borrowed? Obviously 4 is borrowed. And how much was the default? 24 was the default. So 24 plus 4 is equal to 28. So CIDR value will be what? 28. 200, 150, 100, dot 96, 28. Okay, 28 mean what? We borrowed 4 bits. And how many are remaining there? 4. So 2 power 4 is equal to that. Okay, so let's find out. This is the first value, my network value. What will be my last value? Simple, 95 plus 30, not 32, 95 plus 16. 16. So 9 plus 6 plus 5 is equal to 11, 10, 111. Okay, so 200, 150, 100, 111. Subnet mask has changed. 255, 255, 255, 240. Why 240? Because 4 bits are borrowed. Okay, like this. This 240 is the value of this 4 on bits. This is for the customer 3. Sorry. Let's go for the customer 4. Requirements was how much? Requirements were 2. So how many bits will I borrow to give me minimum 2 addresses? Slash 30. Slash 30 mean how many host bits are remaining there? 2. So 2 power 2 is equal to 4. Minus 2 is equal to minus 2 is equal to 2. So 2 is equal to 2. Okay, our requirements were 2, and we will have 2 addresses. So what will be the last address? See, it's the network is start from 1112, and the previous network was finished on 111. Okay, 111. So we have to plus 4 is equal to 115. Okay, so our next network is 100. 5. Finish. Subnet mask 255.255.252. Okay, dears. Now let's compare requirements, available address, and the wastage. Customer 1 requirements was 50. Okay, required addresses. Okay, dears. Customer 1 required address was 50. Required address, available address, and wastage of the addresses. Available was how much? 62. So how much is wasted? 12. Customer 2 requirement was 25. Available is how much? 32. Okay, the valid was 30. How much is wasted? 5. Customer C requirement was 10. Available was 14. So how much is wasted? 4. Customer 4 requirements was 2. Available was 2. How much is wasted? 0. So now the total number of wastage is 12 plus this 17 plus 21. 21 addresses are used. And we are where? 200, 150, 100, dot 116 till 255. Still this much address is available with us. So we have 21 wastage of addresses, and these addresses are what? Free. Before they were not free. You can see before we reached where? We reached 255. Okay. So now this is why we were mentioning here that more efficient further decrease the wastage of addresses. So the wastage of addresses were come to 21 from 159, and the as also support what? Resubnetting. We subnet the CIDR. It was /26 becomes /27 becomes /28 becomes /30. Okay, they were what? Resubnetting. Why we were doing that resubnetting? To further decrease the number of waste addresses per network. So my dears, VLSM is a variable length subnet mask. If your requirement is variable, no problem. The subnet mask length can be changed accordingly. You can resubnet a subnet until to have a perfect match of your available number of hosts to decrease or to keep the wastage of addresses at the minimum level. VLCM is the modern or the new method of comparatively new method of the subnetting, and mostly professionals use this. ISPs use this everywhere. We're using VLSM. Okay, so if you have any question or confusion, you can ask in the comment section. I will definitely reply. Thank you very much. I hope it's clear. In our next lecture, I will have another practical example. In that practical example, we will consider that we will be an ISP, and we will have an address, and we will try to subnet that address among multiple customers, but the customer requirements will be in a few thousand. In this example, the customer requirements were 50, 25, 10, and 2, but over there the customer requirements will be larger. Like let's suppose you are a regional or international ISP and you are giving addresses to national ISPs or domestic ISPs. Okay, then obviously they will required a bigger set of IP addresses, and we will learn how we can deal with that. Okay, so thank you very much. See you in the next video.